everybody. Today we're going to talk about distance of horizontal and vertical lines and also distance of diagonal lines. So remember, horizontal lines go left and right on the page and vertical lines go up and down on the page. But if we needed to find distance of a diagonal line, we're going to use the distance formula. So let's take a look just right now at the top one, horizontal and vertical lines. So here is a horizontal line. And what you notice about this line is that you've got 2 points, and each of those points have matching y values, okay? So the y values are the same. So finding the distance on this line is actually super easy because you could just literally go 1, 2, 3, 4, 5, 6, 7 and say this line is 7 long, right? The whole length is 7, okay? But we could also use a formula or subtract, that's a weird R, the x values. So we could actually take a look at it and go, you know what? The x values are 3 and -4. So I could say I could say x2, right? This is x2. x2 minus x1 to get my formula. So that's 3 minus, and then this is x1, -4. And don't forget, we always have to write this minus sign because it's in the formula, and then -4 is negative, so we have to write that twice. And 3 minus -4 is 7. And if you remember from the last video about the line segment postulate, we were talking about just subtracting to find those lengths. All right, so on this side we have the vertical line. And on the vertical line, they have matching x values, okay? So if you look, our x values are the ones that match for this, 2 and 2. So that's how we can tell it's vertical, just by looking at points. Okay, and then, so to figure this one out, we're going to subtract the y values. And just like we did over here, it's going to be y2 minus y1. You have to do the second one, which is 3 minus 9. Oh, sorry, that's the first point. 9 minus 3. This is x. Or sorry, this is not x, this is y. I need to slow down. y2, and that's y1. So 9 minus 3 is 6. And just like with the horizontal line, we could have gone the easy route and just counted. That's for 6, okay? But what happens when we have a diagonal line like this, okay? So this is CA, and it's actually kind of a diagonal line. So this is going to use a formula, okay? The distance formula is super easy. It starts with a big square root sign. That's called a radical. And here we had matching y values and we subtracted the x's, and here we had matching x values and we subtracted the y's. Well, if nothing matches, then you're just going to do the same little, these are 2 pieces of our formula. We're going to subtract the x's and subtract the y's, okay? But they go in the formula. So the first parentheses would be x2 minus x1, and the second parentheses is y2 minus y1, okay? And then, of course, this is not the whole formula because that looks like multiplication and like that wouldn't make any sense. We're going to add those together after we take the answer we get in parentheses and square it. Okay? So we're going to square when we subtract the x's, square when we subtract the y's, and then take the square root. Okay? It's like 6 steps. So here we go. We got to figure out what C is first. C is at 0, 3. And A is at, let's see, 3 for x and negative 1, 2, 3, 4, 5, 6, 7. -7. So I think it's easiest if you color your x's one color. I'm going to choose green. And so the first part of our formula is to subtract the x's. So we would say 3 minus 0 squared. And it doesn't matter what order you go in for this one. You could go 0 minus 3. Just make sure you continue to go 3 minus -7 if you do the second one. So I subtracted my x's and I wrote it squared. And then I'm going to have to highlight the second letter, which is the y, and I'm going to subtract those. So, oops, I forgot to highlight this green. Okay, plus, and now I'm going to subtract my y's, -7 minus 3 squared. And I'm done writing down my formula. Now we just figure out what that's worth. So 3 minus 0 is 3. I'm going to keep it in parentheses and square it. -7 minus 3, they're both negative, so I end up at -10, and I'm going to square that. And then if you know how to square really easily in your head, you can do that. Some people still struggle with that, so you literally just type what you see on the calculator. 3 squared is the first one. 3 squared is 9, so I'm going to put that underneath the radical. 9 plus, and then -10 squared is 100. And then the last step, whoops, is to combine those. 109. Now you can go to your calculator and you can find the square root of 109. It's right here above the little x squared button. There's a little square root and it's in blue. So you're going to push second square root and that pulls that up and you can type in 109. And when you do that, you get a big long decimal. We're going to be rounding to the nearest hundredth, which is 2 decimal places after the 10, okay? So it's 10.44. The next number is 0, so we're going to leave it as a 4. Remember, if the next number is a 5 or above, then you would change this second 4 to a 5. Now, when we write our answer, we're not going to write equals 10.44 because we didn't actually write the whole number here. There's still more letters, still more numbers after the decimal. So instead of putting that it's equal to that, because that's not true, we're not going to lie about this, we're going to put a squiggly equal sign. This means it's about 10.44, okay? All right, I think that the ordered pairs in a coordinate plane are harder than if they just actually start you with the ordered pairs. I think it makes the problem a little bit easier. So I'm going to go at it again, and I'm going to go with the -1 and the -3 are my x's, and the 4 and the -4 are my y's. Okay, and I'm just going to go for the formula here. So d equals the square root of, let's subtract our x's first. -3 minus -1. Make sure you square it. Plus, and then my second one, I'm going to subtract my y's. So -4 minus 4, and then we're going to square that. And then you just kind of follow order of operations to simplify. So d is equal to, there's 2 negatives here, so that's really -3 plus 1. And if you wanted to do it on your calculator, you could literally go -3 minus -1. That's 2. So -2 squared. Plus, and then -4 minus 4 is -8 squared. Then you go on your calculator and you type in -2 squared, which is 4. And you type in -8 squared. Don't forget your parentheses so you don't mess up, which is 64. All of that's still underneath the radical. All we did was this part. Last, we're going to combine 4 and 64 together to get 68. And then we're going to see what that is. Second square root of 68. And that's 8.246. We want the first 2 digits, but there's a 6 after the 4, so that means that this 4 turns into a 5. So it's about 8.25. And that's it. All right. So if we have a diagonal line, then we can use the distance formula that we just talked about with the radical, the square root sign. But if you look at your points that they're giving you and you notice they have matching y's or matching x's, it's a way easier method to just subtract the opposite letter, okay? So just keep that in mind. Can you use the distance formula even if they match? Yes, you can, okay? But it's way easier to use this formula if you have matching x's or matching y's, okay? So when you go highlight, if something matches, just use the subtraction of the other one. All right, thanks so much for watching, and